Welcome to the AI4HERITAGE Proof of Concept, where we explore innovative solutions to preserve our cultural heritage using artificial intelligence. Let's dive into the key achievements of the AI4HERITAGE Proof of Concept. First, we have crack detection on walls using neural networks. We successfully trained a deep learning model using PyTorch to detect cracks in heritage buildings. This involved implementing a multi-layer convolutional neural network, or CNN architecture, with side convolutions for refined detection. Next, we tackled image segmentation for heat loss identification. By utilizing OpenCV-based image segmentation, we were able to analyze thermal imagery and quantify heat loss in historic buildings. We employed bounding box detection to highlight areas with high heat loss. Now let's discuss the limitations and areas for improvement. One key area is the integration of crack detection and image segmentation. Currently, these two functionalities operate separately and require integration into a unified AI pipeline. Another challenge is real-time processing. Our current implementations are not optimized for real-time detection. Further enhancements are needed for deployment. Finally, let's take a look at the AI model architecture and processing. This section will provide an in-depth understanding of the technical framework supporting our innovative solutions. Machine learning and deep learning frameworks. PyTorch, used for building and training the crack detection model. OpenCV, applied for image pre-processing and segmentation in heat loss analysis. Model components, convolutional neural networks, CNNs, multi-layer Conv2D architecture with batchnorm 2D and RealU activations for feature extraction, max pooling for downsampling, fusion layer, fuse_conv, aggregates multiple CNN side outputs for final crack detection, image segmentation implemented using OpenCV to process thermal images and quantify heat loss. Bounding box detection marks high heat loss areas. Software development and execution Docker used for containerized deployment, ensuring consistency across different systems. Dev containers, VS Code. Dev container enables controlled Python environment execution, Python main programming language. Models, executed via run_model.py. Image processing and quantification. Thermal image analysis with OpenCV. Extracts and quantifies heat loss from infrastructure. Bounding box detection. Identifies max heat loss areas and quantifies inefficiency based on bounding box dimensions. Currently, crack detection and heat loss segmentation operate separately. The next step is to merge them into a unified AI pipeline for seamless analysis and deployment. To enhance efficiency, the next development phase involves model fusion combining crack detection, CNN-based, and heat loss segmentation, OpenCV-based, into a single workflow, ensuring compatibility between deep learning and traditional computer vision techniques. Data pre-processing. Standardization, creating a unified data input format for both models. Establishing pre-processing steps optimized for crack detection and thermal segmentation. Automated processing pipeline. Developing a sequential AI workflow for automated input processing and result generation. Implementing memory management strategies for large datasets. Deployment optimization. Utilizing Docker for containerized deployment and reproducibility. Exploring GPU acceleration to enable real-time processing, validation, and testing. Benchmarking model performance on real-world heritage datasets. Refining algorithms based on error, analysis, and feedback. This integration will provide a comprehensive AI solution for heritage conservation, improving diagnostic accuracy and supporting proactive maintenance strategies. The AI4HERITAGE POC has successfully demonstrated the capabilities of deep learning and computer vision in detecting structural cracks and assessing thermal inefficiencies in heritage buildings. By leveraging PyTorch for neural network-based crack detection and OpenCV for heat loss segmentation, the project has laid a strong foundation for AI-driven heritage conservation. Key takeaways: innovative AI application, successfully implemented AI techniques to enhance the structural assessment of heritage buildings. Scalability and deployment demonstrated feasibility of deploying AI models in containerized environments for conservation efforts. Need for integration. Future efforts will focus on merging crack detection and heat loss analysis into a single pipeline for comprehensive analysis. Performance optimization, exploring GPU acceleration and real-time processing to enhance practical usability. Impact on heritage conservation. AI4 Heritage aims to become a pivotal tool for conservation specialists, helping to preserve historic structures efficiently and accurately. By addressing the outlined improvements and next steps, AI4HERITAGE is set to revolutionize the way heritage buildings are monitored and maintained, ensuring their longevity through data-driven insights.